Okay, Manisa, feel free to get started.
Thank you, Vivian. Thank you, everybody, for joining us today in this event, making our community grow. Some of you are already alumni. People are involved in our community. Some of you are new, and that's why I'm here. Generally, when the students are interested in studying data science, I am the point of contact, the first point of contact of many of the students. So just to present myself, my name is Monisa. I'm one of the admissions officers here in the school. And let's talk a little bit about us before we start the event. I promise I won't take much of your time. Yeah, everybody's excited for today's event, but let me just share a little bit, like I said, talking a little bit about us, and again, invite that anyone that is interested in studying data science, feel free to talk to me either during the event. I'm here available in the chat, or we can schedule a call. I'm happy to hear about your career and your plans and assist you with information about the course. So again, welcome everybody. To start, I would advise also people make sure that your mics are muted so there's no sound interference while people are presenting. And that's just one little tip. And then if you have questions, feel free to utilize the chat. Our staff will actually be checking for questions so we can also communicate. Well, let's learn a little bit about NYC Data Science Academy. Our school are very proud to offer data science training. We're the only boot camp teaching both Python and R, teaching 2 programming languages, and we are known for hands-on learning and for. Oh, hi. Just want to make sure if everybody can mute their mics for now. Because we can hear some sounds. That would be great.
Don't worry, I'm muting people. Manisa, I'm muting people, don't worry.
Oh, thank you. So like I was saying, we are known for offering the students the opportunity to work on hands-on projects, real-world projects. We are also famous for our job placement career services, providing all the students our networking and career service, not only after graduation, but even after you get your first job. That's why our community is really strong and always connected. We're always here for you post-graduation. We're known for helping over 2,000 alumni working, across the globe. And not to brag, but we are also rated as the best data science bootcamp and best online data science bootcamp by SwitchUp in 2020. So just quick reminder, we can catch up this toward later after this event, but we have upcoming data science bootcamp start sessions. We have our remote live that will start May 3rd. If you are planning on this date, there's still time for you to submit your application. It's a good time actually for study planning. It's enough time for you to work on the pre-work. It's a great time to apply now for the May 3rd. We also have our part-time online and full-time online bootcamp starting the upcoming date will be April 6th, and then another one May 17th. So if you have any questions regarding the full-time online or the remote live, part-time live, if you want to discuss what are the differences, feel free to contact me. Yeah, this is the email. If you have any questions about the programs, the start dates of our school, I'm happy to talk with anyone interested in studying data science. So let's start the event. Thank you, Vivian.
That's awesome. Let's switch to Rami. Rami, feel free to share your screen.
Cool. I'm just always challenged with working with Zoom. I usually use WebEx, so I hope I'm sharing.
Don't worry.
The right screen.
Everyone, while Rami is sharing his screen, I'm sharing you today's stack. So feel free to grab the link from the chat.
So, Vivian, can you see my main screen?
Yeah, okay. I can see it well.
Okay, all right. So thank you everyone who joined today. And thank you for Vivian for hosting this event. So today main agenda is talking about deploying data science project into production with open source tools and why it is important as a data scientist to be able to deploy our projects into production environment. So before we start, just a little bit about myself. I'm a data science manager. As you can see on with the hexagons and the picture on the right side, I love R, time series. I'm author of hands-on time series analysis with R. And I'm the author of several R packages that focus mainly on time series. I consider myself as a mediocre DevOps data engineer. It's not my main thing that I'm doing on a day-to-day, but over the years, I become one as a necessity as part of being data scientist. So the agenda for today is give you some motivation, like why you want to be able to deploy your project into production. Talk about case study. Going to talk about dashboard I built for showing this use case of forecasting the demand for electricity in the US. We'll go into details and tools, and at the end we'll leave some time for Q&A. So, and then like the real agenda here is to advocate or convince you that along the, the cool tools that you learn as a data scientist, like modeling, R, Python, I would encourage you also to learn how to work with Docker, Bash, Git, GitHub Action, and this type of tools. I mean, if I had to give myself advice to myself 5 years ago, the advice I would give myself is learn those tools. So I hope I will be able to convince you. So in order to understand why it is important, we start with the data science project workflow. And typically, the first steps is to define the business problem, to understand what we're trying to solve. It could be we're trying to understand what our future unit sales, customer churn, capacity plan. And typically as data scientists, we will either use R, Python, and other tools. Once we understand the business problem, the next step is to find the data. Once we kind of like understand where is the right data, we probably need to write to some API database and do some transformation. And once we get to the point that we have a clean data, this is where the fun starts, and we starting to have the scripting analysis where we are trying to get as much insight about the data that we have in the context of the business problem. And sometimes this is what you need, and you solve the problem by just plotting the data. But in some cases, you also want to do some prediction analysis. And then like you're leveraging what you learn on the descriptive part, you use those insights and put it in some models and build some prediction. And then the next step is to communicate your results for the different stakeholders by building dashboard reports, API, and so on. And the last step is to deploy it into production. Now, it's not a secret that the first part I feel take most of the time. I feel like that trying to find the data, define the business problem is like 70% of the time. 7% of the time that you will spend on the project, and the rest is roughly 30%. Now, if you, in an ideal world, this is kind of like a team structure would be. The business problem will be defined by some business analyst or business team. You would have like data engineers that would help you to pull the data. And the real data science work would be to analyze the data, create a prediction, maybe to visualize it, create some dashboard. And then once you're there, you push it to some DevOps team that put it in production. In reality, most of the case, you won't, if you're working in a small team, you won't have a data engineer to help you, or DevOps team. And you might or might not have a business analyst, but from my experience, I think most cases I didn't have data engineer or DevOps. And this is where it's become very challenging. You are building some model, but you cannot really communicate. You are in this era that you are, all your work is done in on your laptop. You are sending CSV file to the different stakeholders, or you are rendering some HTML file, but you're not really be able to put it in production. And it's really annoying. And then, like, if you think about the definition of, my definition for full stack data scientist is having the ability to do all those steps. And I think that the future is, as a data scientist, is this full stack, be able to create automation and productionize your work. And if someone tell me that, look, I know how to build fancy machine learning or deep learning model, it's cool, it's important. I definitely recommend you to learn all those tools. But if someone else tell me, I can take a linear regression and deploy it into production, create data pipeline, create automation, and put it in some automation, for me, it's a god. It's someone in that level. It's much more challenging to be able to deploy it into production. So with that, I want to talk about productionized open source projects. And in my case, this is where I learned some of my DevOps skills. It's started about a year ago or a bit more than a year ago, when the COVID-19 started. Somewhere around February or end of January, when it's only was a problem in China, I decided to pull the data. John Hopkins went with their dashboard, and I found the repo and decided to package it into R package. And for those who are not familiar with R, it is very common to build a package with only data. I don't think it's as common in other languages, but in R, it's something very common. And I thought it's a nice way to track time series, because I'm a time series person. Really fast understood that this is more than just regular time series. You cannot really run models. Decided to leave it to the biostatistician to do the analysis, but I started to pull the data. And then I realized that the data is keep updating. Like normal R package, you are pushing it into Crane, or you refresh the data once every few months, if not one time. But this is a different case where you want to refresh it on a daily basis when the source is getting refreshed. And I went into this kind of like trying to understand, how can I use open source tools to create a data pipeline, which is very something that I'm still doing in my work, but it wasn't that intuitive in the open source world. So then the next step was to create a Docker. This is kind of like the format of a package. And I combine it with GitHub Action, which is, at that time, was really relatively new tool that enable you to trigger jobs, run cron jobs, and apply some functionality. And what it does is refresh the data. And this is like a screenshot I took this morning, and it was like 4 hours after the data was refreshed. And since I put it into some format of production, it's very stable and it's just running there. And with that, the appetite came, and I realized that, hey, I can run automation to create the data pipeline. This is really cool. So why don't I build some dashboard that provide some insights about the data that I'm pulling for the COVID-19, and I create this dashboard that get updated on a daily basis with GitHub Action. running inside the Docker environment. And I added this part about like the description about what the structure of this dashboard, under the assumption that people might want to use this code to create their own dashboard. And surprisingly, I mean, I didn't expect to be as popular, but like dozens of people actually went and forked this dashboard and create their own version. And I was really excited about it. I felt that I opened for many people the door to go beyond just creating stuff on their laptop and helping them to deploy it into production. So I said, like, why don't I will create some example that is kind of like more data science example, because this dashboard is provide descriptive, but it doesn't provide the predictive. And then I came with this dashboard or project that the goal of this project is to provide example of deployment of a full data science project. And this is kind of like refer to the last step of your project, like after you create your model, your modeling, the descriptive analysis, and you want to share it with other people and put it in some automation in production. So I create this dashboard. The main information it provides is the forecast, a 3 days forecast for the US total demand for electricity. And provide in addition some descriptive information about the supply. But that's it. It's a very simple dashboard. The goal was not to create something fancy, rather to show example about how you take a machine learning model and put it with GitHub Action in a dashboard using mainly open source tools and free tools. So what does this dashboard does? So it's provide visualization with it's a static dashboard that provides interactive visualization with Plotly. It's based on our Markdown package, which is our package that enable you to create different format of Markdown. And one of those is the Flex dashboard, which is static dashboard, which is really cool way to create a on-the-fly dashboard. And the dashboard is refreshed and rendered hourly. So the source data is refreshed on the API every hour. So every hour there is a cron job that go and check if there is a new data. And if there is a new data, it's pushing into the dashboard. The second component is the forecasting model. And the forecasting model is based on generalized linear model, or GLM, which is, I'm using the H2 implementation, which is essentially linear regression with ridge and lasso, a combination of ridge and lasso regularization. Because I'm using a lot of features, it's hourly data, so I think I'm using about 30 or 40 variables, and you want to have some feature selection. So that's why I decided to use this model. Also, it's an example how you can deploy a machine learning model. I could use, instead of the GLM random forest deep learning, it doesn't matter. It will still work the same way, because if you can deploy the H2O inside the Docker, anything else will work. The main feature that I'm using for the model, the seasonal component you have in electricity. If you can see it, like it's a very high seasonality. You have hourly effect, monthly effect, day of the week effect. I'm using the trend, the legs features, and that's it. Is a very simplistic model. In addition, I created prediction intervals, because that's the way I like to communicate any prediction with the uncertainty that involves. And this model is running every 72 hours. So once the forecast is getting to the point that all the actuals are the same point as the forecast, it's refresh the forecast and generate the next 72 hours. So far it's a very standard, and we can keep going and talk about how fancy the model or what model we build, but it's really boring because the interesting stuff on this is the architect behind of it. And I promise this is the last slide with my favorite cartoons. And I think that what is really interesting in this is the architect behind the ability to create automation. So let's pause and talk about that. So this is a general structure of this project. So on top of it, you have the GitHub action, which is the scheduler. What it does, it just trigger code. In order to trigger this code, you need an environment. So that's why I'm using the Docker, that I set all the environment that I need to run the R, H2O, Markdown, Plotly, and all the features that I have here installed inside this Docker. So anytime I'm calling the code, it's based on the environment that's set on this Docker. The main driver is R. So the data pool, the modeling, the visualization, and everything is running with R. That being said, you can easily change the whole format to Python. If you're a Python person, it can be done. Also with Python, H2O and Plotly are packages that are both available in R and Python. I use Bash. It's a great tool as the helper. If you need to run some script in the terminal, and this is how you can think about GitHub action that you are speaking in a terminal. So to automate some scripting when you want to run multiple R codes, so Bash is a really nice tool. The data I'm pulling from EAI, which is Energy Information Administration. It's a website that provides a lot of information about energy data in the US, like gas consumption, electricity, and others, and all the data is coming from there. And I'm use JQ, which is a great tool to parse JSON. I'm pushing it to the script. I'm checking if I need to run the forecast. If I run the forecast, I have a pre-trained model with H2O that I'm pushing the forecast. And at the end, if there is any updates, there is a new data, it's re-rendering all with Plotly and our Markdown, and pushing it into GitHub pages where I'm deploying the website. So I can just pause for a second and go and show you how the dashboard So this is the actual dashboard. As you can see, this is the information it provides. This is yesterday. It was the last time that it triggered the forecast. It's set by Eastern time. So at midnight, it set a new forecast. Since it triggered the forecast, on average, the error rate is 1%. The coverage, which is measuring how many of the actuals were within the prediction interval, is 100%. And the bar below, it's the supply data by energy source. Okay, this is so let's jump and talk about the interesting stuff from GitHub Action. So GitHub Action is essentially a manifest which enable you to define when, where, and what. And this is the whole code that is running on GitHub Action. It's that simple. So it's a YAML file that enable you to define how often you want to run the job. And here I set it to run every hour at the beginning of the hour. So you see on the right side, there is, if you're not familiar with cron job, you can define the minute, the hour, the day, the month, and day of the week. And here I'm setting it to run every hour at the beginning of the hour. The where is here defined. GitHub action enable you to set the OS that you want to use. And in this case, I'm using Ubuntu. And the main reason that the Docker is running on Ubuntu, so I'm using the same environment. And here I'm calling the Docker that I'm using to run this environment. And this is pulling it from Docker Hub. Docker Hub is, if you're not familiar with Docker, Docker Hub is kind of like the GitHub that have similar functionality as GitHub, and this is where you store your images. So this is like I'm calling this dedicate Docker, which you can see on the right side. To create this Docker, I have a bash script that automate the process that run Docker build, which is called, called the code on the right side, which is defining what I want to run. And this is essentially, if you're familiar with a Docker file, I tend to have like a really simplistic Docker files with max 10 to 20 lines of code. And all the work I'm using helper script that I'm triggering from the Docker file to run those. It's much more convenient and it's cleaner. So here, essentially, I'm setting the environment. I'm loading a base R Docker, which is Docker that has the basic components I need to run R. And on top of it, I'm running a script, which is the one that you see on the right side below, that is installing the packages that I need for this dashboard. The next step is to define which branch do you want to use. I'm using here the main branch. And the last step, you're defining what you want to do. And here I'm essentially saying, I want to run this bash script. And you can see on the right side, this is the bash script, the triggering R code that check if there is a new data. And if there is a new data, it's a check if you need to refresh the forecast. And if the forecast, you don't need to refresh the forecast, but you have a new data, it's rendering the dashboard and pushing the changes. I'm also, it's enable you to use a secret. So for example, and this is something you would typically have to do when you are calling APIs or database, you have to keep your authentication keys in a safe place, and GitHub Action enable you to store those, and I'm parsing it and pushing it to the API. So that's it. That's the whole, that's it. This is how simple it is to deploy this type of dashboard. If you have a basic knowledge in R or Python, all you need to do is to be able to create environment, which is the Docker, and be able to run a GitHub action that, coordinate those scripts, trigger them, and pushing it eventually the changes back to your repository. So let's talk for a second about the data. So I'm pulling the data from the EIA API. And this is really one of my favorite API because I'm a time series person. So there's a lot of good examples for time series over there. But it's one of the rare API that give you hourly data, which is not that common. Not many APIs provide you hourly data. Usually for time series you get daily, monthly, but here they provide you a live hourly data of the electricity. So this is where the source of the data. If you are looking for fun data to play with, I recommend to go to this website and check it. So the last thing I want to say about the dashboard that it is still work in progress. It's kind of like I have like a side project that I'm doing as a open source contributor, and typically when I'm going to a project, I have in mind like how long it's going to take, and usually it's like triple the time that I'm thinking about when it's starting. It's kind of like very tempting to add additional features. But it's still work in progress. It's something I'm doing as a fun time during weekend time. But this is kind of like what I'm aiming to get this project. I want it to be fully automated and functional. So it's halfway over there, but essentially I want to create like a JSON with setting that if someone want to fork it and can change just a setting over there and convert this dashboard from the forecast of the total electricity in the US to the forecast of the total electricity in California or New York or other state. The other thing that I trying to make it as much as reproducible for others, that people can do the same as with the COVID-19 dashboard, that they can fork it and create their own dashboard. And it shouldn't be necessarily only electricity. It could be demonstrate solving other problems like classification, regression, other time series problem. But essentially, if you understand the structure, you can deploy anything that you want inside. The last, before the last, is to improve the data visualization. Now it is very basic. The goal was not, the main goal was to create something to show how to push in production. So I put a lot of effort on the backend. I didn't put much of effort on the visualization. I can see it going in a, be much more nicer or adding additional information, but it's something away on the road. And the last and probably the most important, to create documentation that people can use it and understand how does it work. Here are some resources. I shared with Vivian, so I'm sure she's going to share it. But essentially, like if you want to go and check the code, I shared the dashboard, the code behind of it, GitHub action. If you didn't use GitHub action, I recommend to go and give it a try. It's a really cool and free tool. The same for Docker. And the EI API is also, I put it over here. So maybe I have a few minutes before we can go into questions. So I just go over some of the code just to go. So it's over here. It's called the repository. It's called US Electricity. And this is how it's look like. It's still a bit messy, the code. But essentially the Docker, all the files that are related to Docker are in the Docker. So if you want to go and pull the Docker and build your own Docker and use it as a base, essentially you can clone it and modify it to the, according to the needs. If you need other packages, you can just change the script and create your own Docker. The other component is the functions, which is one function that is created to update the data. The other function is to create the forecast. And those function is to connect to the EI API and pull the data. And this is something I'm still work in progress, setting a JSON with all the parameters. So essentially, when you fork it, you just run the file that go over the JSON and trigger everything. So it should be fully automated based on the information that you put over here. The data. So here's the thing. It's because I'm using a free tool. So I'm storing the data over here as RDA file, which is our format for data. Essentially, if I add, if you want to take it to the next level, I would create like Postgres or any other data format, put it in some AWS, and have some kind of like relationship database. But for the size of the data, this is the data like the format I'm using, and just for the example, as you can see, that was refreshed 20 minutes ago. The actions, so if you want to go and see what are the actions, this is the file that triggered the action, that one that I showed before. It is that simple. If you understand now the structure of YAML file, I think it's a very straightforward to understand, and they have a good documentation. The last piece is you can see the work. So I think if we can go, let's see when it's refreshed. I hope I will find the one that refreshed the model, which ran about 6 or 7 hours ago. So here, this is the way it's work. It's running. It started job. It's pulling the virtual machine, pulling the Docker. Not sure what is this error, but it worked, so I'm not worried about it. Check out from the main branch, and then running the code. So this is what we care. The other thing that I'm doing, I'm putting a lot of messages, like you see those colored messages, because when you have some problem and you want to debug, this is a nice way to go and understand where you have a problem. And this is the point when it's refreshed the data and it's rendering the dashboard and pushing it back to the GitHub action. Let's maybe go and see. Oh, so yeah, the really last thing is I'm running, this is the dashboard itself. So it's R Markdown. And when I trigger it, it's rendering it into HTML file, and you can see it's less than one row. That's how simple it is. It's just putting the visualization, loading the data, and putting it in a dashboard. And once it's rendered, it's push it into docs and create index.html. And if you go to your, if you're familiar with the setting, this is how you deploy a website in using GitHub Action. So if you are saying, I have index.html in my docs, usually this is the default folder. Once you set it, it will give you endpoint, and essentially this is the dashboard. So with that, we'll pause and see if there are any questions.
So Rami, if someone wants to run this app on their local machine and they download your GitHub repo, what's the quick way to set it up?
It's a good question. So if you fork it and download it, assuming that you have the requirement packages, and maybe I should add it into the documentation, or you can run the Docker, like you have here, install packages. If you have those packages, you can just render the index.rmd and you get the dashboard. So those are the requirement packages, but if you already have them installed, so you essentially go to this index and render it. So I can show you in our studio how it would look like. So this is the dashboard. And if I will just knit it, this is how it would work in our studio. Now the data is not refreshed because I didn't pull. I can pull the data to be, so let's do that. I can pull to the most recent data that is now live on GitHub and re-render, and you will see the same thing that you see now on the website. My machine is behind the one that's available on GitHub. But essentially, it's that if you are familiar with our Markdown, it's as simple. Okay, so you see it's refreshed at 1 o'clock. The data is most updated until 1 o'clock. You see that it's a bit different. So if I will refresh this, you should have the same, exactly the same. So now we are aligned with the one that's available on the dashboard. Does that answer your question?
That's perfect. Yes, that's perfect. I want my audience be able to try it out right away.
So I encourage people to go and try, and I created that people could go and fork it and create their own dashboard. So if you like want to go and try to do something else and you have questions, file issues, I will be happy to help if it's something I can help. You have here the issues. So if you have any questions or something is not working, please feel free to file issue.
Cool, Rami. I have a question to the audience today. I think Rami's work is very universally applicable to many resources and many applications. Do you have a case you want to apply his workflow? Is there other data sets or business cases you want to handle use this workflow? Water demand.
So I actually checked the water demand a couple of days ago. It is also cool time series. And you have, if you want, you can actually convert it easily to this because there is a great API. If you Google, there is for the US, it's not the water demand, but the water level, the sea level, which is a nice time series, which is very seasonal. So I'm sure there is also for the water demand.
We actually partner with American Water. I don't remember, we have 7 or 8 students working at American Water now. If it's this something interesting you, I could definitely make an introduction and see what kind of data we can get from them.
Yeah, I'm always interested in if you have I'm a data freak. If you have a cool data set.
We also see comments like if we can add the cost of the electricity or water would be interesting.
Yeah, so the reason I did not do anything beyond this is time. But there is cost available. I thought about adding CO2 emission that this generating. There's a lot of other stuff that you can do. It's the question like a function of time and how much you want to go deep into it. So I recommend to go to the EI website and check what other series that they have.
Cool. Another suggestion is to show a dashboard to see vaccination rate across USA. So till what time the whole US can be fully vaccinated.
Yeah, I mean, this is a cool visualization if the data is available. Essentially, like I thought about adding the vaccination in my COVID-19 dashboard. Again, it's like a time limitation, so I kind of like narrow down the scope for this only for that. But if people, they have the motivation, I encourage them to, they have a good start. Like I give people like the good start, like they can fork and go wild. And that's what happened with the COVID-19 dashboard, that people, I create something very simplistic and people create really amazing stuff. So I was impressed with what people did with that.
Rami, would you mind share with us your COVID-19 dashboard?
Yeah, sure. So
I saw Eugenia mention zero rent index can be automated and utilized this. Eugenia, would you mind comment on that?
Yes, can you hear me?
Yes, I can hear you. How do you think this can be applied to zero rental index?
Oh, yeah, Vivian, I'm in current New York data science cohort, and we are working on the capstone project on predicting Zillow rent index. So we have like historical Zillow rent index data, and the main goal is to predict and probably try and forecast the rent index. So I see it as a great opportunity to try. So thank you so much, Rami. It's very exciting.
yeah, it's a cool subject. They Zillow provide API, so I actually checked like we thought about buying house in the areas, and then I went and pulled the data and I discovered that they have a cool API. So definitely it's something that they provide a lot of data about renting and selling. So it's a good place to pull data.
Great.
Interesting
Thank you so
topic.
much.
Rami, would you mind copy paste to send to the chat so people can check out your dashboard?
Yeah.
I think this is something New York Times or Bloomberg newsroom would love to publish, like how fast the whole country can be vaccinated.
I mean, I'm sure people
I can
are
even imagine it's a competition.
Yeah, I'm sure people are already doing it. Where is the chat?
Yep. Also, Rami, I have more questions from the audience, if you don't mind.
Sure.
So Jesus is asking, what's your thoughts on learning Kubernetes? Would that be a more complete full stack solution?
I think this is the next steps. I can say that this is where I stopped because I didn't, I had to. I wanted to focus. I started a bit to learn Kubernetes, but then because of a variety of reasons, I didn't have to continue, and I was focusing more on Docker and automation. But it seems like Kubernetes become something big. So if you also can learn Kubernetes, this is awesome.
I see. So all the Data Science Academy alumni were producing 2 topics to support your continuous growth. So in the end of the month, we're going to release a course to how to deploy apps into Amazon Cloud in 15 minutes. And the other course is Kubernetes intro. So you should receive our email announcement soon. And Rami, I'm happy to connect you with our alumni who's super familiar with Kubernetes and see whether you guys can collaborate.
Sure. This is like an awesome tool. I don't have much, like I use it briefly, but this seems like one of the next thing to learn.
Sounds good. So next question is from Cisa. Rami, how would you compare your setup to some semi-out-of-box solutions such as Streamlit?
So this is not. So I'm trying to make it as out-of-the-box solution with creating like auto setting with JSON file that you can go and say replace the US total with the California total. But again, it's like the amount of time that I spend on it compared to out-of-the-box solution, it's not going to be out-of-the-box solution, to the level of enterprise. But it's more fun and learning experience. So definitely not out of the box. It was not the intention to be out of the box.
I see. Sound good. So I think data science is very much about hacking. As long as you can hack through, make things happen, make it fast, and make it perfect. Right?
Yeah.
So Jesus have more questions for Rami. Any tool for CI, CD, CT you can think worth learning? Maybe Kubeflow.
To deploy it in Kubeflow. Yeah, I mean, so I think the next step is to go to AWS, or if you want really something. So the limitation of a GitHub Action, it's a free tool, so it comes with some limitation. And so if you want to run something more heavy, so definitely you should go to some, Google Cloud or AWS or all those tools, cloud tools that you can either use Kubernetes or some more robust resources.
Sounds good. So there another question say, anyone have recommendation for free resources to learn the topic of data science? I share link is our blog post. We have around 1900 blog posts on different data science user cases. A lot of shiny apps, a lot of dashboards, Dockers, machine learning. Feel free to go there, and they are freshly updated every week and month. So feel free to check it out.
Shiny is a super cool tool, so highly recommended if you are in the R ecosystem.
Every student graduate from NYC data science have to do a Shiny app. It's mandatory. Another question,
awesome.
Rami, do you have any thoughts on Python Dash?
It's a great tool. I would love to learn more. Like, it's on my to-do list. And again, it's coming to time allocation. I have a lot of my to-do list. I know you cannot see, but I have like tons of books that waiting, like T3, Bayesian statistic. Dash is one of those. And if you're Pythonic, so if you want to do something like Shiny, Dash is what you want to learn.
Sounds good. Another question is, can I share the link because you joined late? Yes, definitely. I'm happy to send all the GitHub links, all the slides deck. I already shared on the linking event sharing, and we're gonna follow up with newsletter too. So if you have signed up to our newsletter, you should be covered. So another question for Rami, can your project be replicated for AutoML workflow?
Yeah, H2 AutoML, this is, yes, definitely. The main caveat with the AutoML is that so I'm running so I trained the model before on my machine. I capture like what are the tuning that I should use. And then when it's refreshed, it's using, let's say, based on the setting, it's using on GitHub Action. If you want to run live AutoML on GitHub Actions, you may have like a resource constraint. And then the other limitation I can see, it's not limitation, but it requires some more effort. If you want to generate confidence or prediction intervals, might be, you need to do some bootstrapping or something else, because for the native XGBoost or deep learning models that it provide, you cannot generate prediction intervals.
Cool.
But definitely, awesome. It's a awesome tool.
Rami, I think you shared the wrong link to your COVID-19 dashboard. Would you mind share one more time?
Yeah.
So I have a question for the audience. Like Thomas, as a data scientist at Data Robot, how do you see you guys are deploying this kind of AutoML workflow now?
Well, no, I mean, their deployment is like the most important thing, I would say. Actually, being able to make predictions to provide value. So I think that's why what was interesting was, yeah, I mean, was what I think was the most important thing to take from this, from Rami's code and his talk. So that's what I'd focus on first. And then afterwards, you could always work on the, the modeling and the machine learning and the statistics behind that. So I thought it was great,
Sounds
Rami.
good.
Thank you. Yeah, try to make it modular. So essentially, like, you can go and replace the GLM with any other models that are available on H2O, and essentially, like, you can, replace the code with your own code that's running different solutions. So it could be tidy models in R, or scikit learning, or any other thing, Keras, name it. It's as long as you have a support, you install the support on your Docker that support the models that you want to run, it will work. And then again, like, if you're running some heavy deep learning models, you need to make sure that you have the resources. So because of the purpose, I wanted just to show that it's working. I choose for light model. If you want to go really wild, you can, get it on AWS or Google Cloud or any of those cloud solution and run something more fancy.
So Rami, have you done a lot of like complicated model using this workflow, like stacking different model, ensemble model, like really time consuming model, like random forest, XGBoost?
Yeah, I did it in my previous work. I think it's I feel it's like some kind of like level of maturity in my data science life, that you start with the most fancy stuff and eventually you convert to linear regression. I found that, TSLM, like, I'm in the domain of time series. TSLM is time series linear regression model. It's usually where it's the most optimal model for most solutions. So usually I'm running multiple models and run a horse race, and then I select the one to perform based on the backtesting. And backtesting is the machine learning equivalent, or the time series equivalent to the machine learning cross validation. So yeah, I found myself that it's easy to prototype with TSLM, and TSLM is essentially, it's just the engine. Like, if you can replace it with any regression model, but then when you compare it to other models, and most of the time this is the winning model. Usually, like, TSLM with ARIMA errors is in time series is the main model, but you can definitely go, like, the question is, like, if you're going to use like AutoML or with fancy TensorFlow or XGBoost, what is the cost benefit? So you can train a model for, let's say, half hour, 1 hour, and what is the cost that it's worth to use it? Like, in terms, like, if you improve the accuracy, but you spend 1 hour as opposed to running something in 1 fraction of a second on 1 CPU. So you need to make this, cost benefit calculation. So over time, that's why I converge to time series. When you need to forecast 1,000 series, it's much more scalable in terms of resource and cost and reliability.
I see. Rami, my last question is, what's the best user cases you have found so far using time series? Really give people a lot of actionable insight.
So I cannot talk about my work, but I can say that the models I'm creating helping to make a lot of decision, and this is why I'm happy what I'm doing. That you can also see that the results are impacting the decision that are being made by different stakeholders in my company. And it's really nice. Like, in some cases, you may build some model, but if people are not going to make decisions based on this model. So it's, and I had those cases that you build models, but then like, the people that work are not really can have the tools to appreciate what the models, the prediction power and all the things. But in the point that I am now, I think that it's nice to see the important decision made based on those models. So it's a data-driven world.
Sound good.
I hope this is answer your question. I know it's a bit vague, but I'm kind of like under limitation.
I think a lot of finance people want to know if you can help them to hedge the model, really make money for hedge fund.
So I would say, and this is, in the time series world, I see like people taking time series model and try to predict stock price, and I feel like this is not what time series models. You can predict stock price if you if you convert all the information that affecting stock into features, and most of those are not available. Like if you think about like what is shifting stocks, like like some news, like Warren Buffett's, sell. It was invested in some stock, and then his sell is holding in one stock, and then like the stock is falling, or Trump tweets, or there is some kind of an element of NLP if you can convert those information into what is driving. So you can, but unfortunately, I think there's like I had a professor that used to tell us that if you like about some model for like stock prediction, that if you ask where is greater than 0.5, you probably get a Nobel Prize. So nobody so far found a way, but I think definitely you can leverage, to make a data-driven decision. You, not in the context of forecasting stocks, but forecasting other stuff, definitely. If your data has patterns, definitely you can, it's sometimes nice to see like how accurate your forecast. So yes, definitely I can see the use case.
That's awesome.
I mean, in reality, the people are using it to make decisions. So in finance, so it should be all over.
That's awesome. Thank you so much, Rami, for giving us such a lively and engaging workshop about your own application. I see it's super useful, universally applicable to a lot of business cases. I hope I can bring you back a few good follow-up cases. People utilize your work.
I would love to see it.
Sounds good. Thank you everyone for attending. I see a lot of alumni and friends from the community. Thank you so much for coming. And next week, we also have another workshop with a current bootcamp student, Martin, and he's currently SVP at Salesforce. So feel free to sign up for the following events. Sounds good? Having a wonderful day, everyone.
Thank you everyone for joining. Thank you, Vivian.
Bye, guys. Thank you.